Hi everybody, this is Mr. Rocco here, and today we're going to be working on our quest check-in called Patterns in the Cascade Range. And what we're going to be investigating is how can you use the history of Mount Rainier's eruptions to decide whether hiking around Mount Rainier is safe. So we are going to be looking at a whole bunch of data on when volcanic eruptions have occurred from a variety of volcanoes that are in the Cascade Range. So if you look at the map here, these are all different active volcanoes. So here's Mount Rainier, that's the one we're looking at for our quest kickoff. But we're going to look at data from a variety of these volcanoes, and we're going to look at the history of when these volcanoes last erupted. So when you look at the data, you're going to see that we're talking about going back thousands of years. So you might say, well, how do we know if a volcano erupted 3,000 years ago? And what we do is we look at the layers of rock in the surrounding area, and it turns out that we can identify layers of ash that have been preserved in the rock layers. So the deeper down you go in the layers of rock, the older it is, because that rock was there before the ones that formed on top of it. So what we're going to be doing is looking at this data and trying to come up with an idea of whether or not, based on the eruptions in the past, if this would be a safe place to go for the next 2 weeks on a hiking trip. So it says, welcome to your first check-in. Remember, your quest is to decide whether it would be safe to take a 2-week hike on the Wonderland Trail around Mount Rainier, which is, after all, a volcano. In this activity, you will take a closer look at the pattern of eruptions on Mount Rainier and surrounding volcanoes to see what this might tell you about future eruptions. Mount Rainier is part of a mountain range called the Cascades, which includes many volcanoes. Located in the Pacific Northwest, the Cascades extend from Northern California, United States, to the southern British Columbia, Canada. Also, I want you to notice that on this map, off the coast of Washington, Oregon, we have a plate boundary. Okay, remember, a plate boundary is a dividing point between two different chunks of the Earth's crust that are moving. So we have this thing, this is called the Juan de Fuchsia plate, and what we have here is we have a small mid-ocean ridge in this area where the plates are kind of pulling apart. And then we have a deep ocean trench in this area where the plate gets subducted because it's more dense, and so as this plate moves this way, it actually dives down into the earth. And so we're going to be looking at how does that have an impact on the formation of these mountains and volcanoes to the east of us. So we're going to be trying to analyze this data. So it says, analyze the map of the Cascade Range. What observations can you make about the location of the volcanoes, both in relation to each other and to the plate boundaries shown? So the question's basically asking you to look at all of these triangles. These are the location of volcanoes. And it's asking you, what do you notice about where those volcanoes are in comparison to where the plate boundary is that I showed you over here? What do you notice about the pattern? One thing I noticed right away is, pretty much if we draw a line through the middle of these volcanoes, they're basically found along a straight line. If we compare that line to where our plate boundary is, you can see it's relatively in the same direction, and it's basically aligned with us, so that's interesting. Okay. So you want to write down some things you notice about where the volcanoes are located compared to the plate boundary. For number 2, scientists studying Mount Rainier are very interested in the volcanic history of all the Cascade volcanoes. Why do you think scientists studying Mount Rainier also study other volcanoes in the range? So if we are focused on Mount Rainier, but we have all these volcanoes in the area, and they're all very close to this plate boundary, would it be possible that other volcanoes that are erupting may give us a clue to when Mount Rainier may be erupting. And that's what we're going to do in this check-in. We're going to look at data from all these different volcanoes to see if we can find any patterns between the volcanoes that are erupting that are similar to Mount Rainier to see if we can make a prediction of when it'll happen next. Okay, number 3 says volcanoes in the Cascade Range have been erupting for over 500,000 years. The timeline in the pictograph shows eruptions of several Cascade volcanoes over the past 4,000 years. Each volcano symbol represents an eruptive period or time when one or more eruptions occurred over a few days, months, or years. Use the timeline in the pictograph to answer the questions below. So on the left here we have all the different volcanoes that we were looking at on the map above, and on our x-axis down here we have how many years ago this volcano erupted. So I'll use a different color here. Basically the graph is set up to basically every vertical line that we go over this way, we are gaining 500 years of time. So present time would be right here. So if we have a volcano that's marked on this line, that means it just erupted this year. As we go back this way, we're looking at volcanoes that erupted in the past. So if I was looking at volcanoes on this line, we're going to say they're have happened about 1,000 years ago. If I'm looking at volcanoes on this line, we're going to say that this is about 1,500 years ago. If I'm looking at volcanoes on this line, I'm going to say it's about 2,000 years ago. If I was looking at ones on this one, I'm going to say it's 3,500 years ago. Each line, as we move to the left, represents 500 years. So we're going to look at this data, and we're going to use it to try to analyze the graph and answer some questions about it. So our first question says, look at the pictograph. What do you notice about the pattern of eruptions at Mount Shasta? So first thing you want to do is you want to find Mount Shasta, which is this one right here. And then so if we start here on the oldest eruption that we can see is a little bit past 3,500 years ago, maybe about 3,700 years. And then we also had an eruption around maybe 2,800 years ago, and then right around maybe 2,100 years, and then right around maybe 1,700 years ago, and then more recently around 1,000 years ago. And then it looks like probably about 250 years ago or so, that was the last time that Mount Shasta erupted. And so it's saying, what do you notice about the pattern of eruptions at Mount Shasta? Well, if we write some things in here, it helps us kind of see the pattern better. So we know that between each line is about 500 years. So between here and here, it's about 500 years. So this one, if we were to go from here to, if we were to go from here to here, that'd be exactly 1,000 years, but you have it a little bit less. So this is maybe about 600 to 700 years apart. But then you notice these two are actually pretty close together. They're probably about 500 years again. Then it looks like we had two volcanoes eruptions that were very close to each other right here, so maybe within 100 years. And then it looks like we have a gap of about another 500 years. So the pattern isn't perfect, but it looks like about every 400 to 600 years Mount Shasta erupts. Okay, so we can say it appears that every 400 to 600 years, Mount Shasta erupts. Okay, for the next question, is there a pattern of eruptions from Mount Rainier? If so, how would you describe the pattern? So this is the mountain that we're looking at, evaluating if it would be safe to go there for our quest. So this is Mount Rainier, and you can see that it was very active volcanically, from 2,000 years ago to about almost 3,000 years ago. And if you look more recently, it looks like it hasn't been nearly as active. The most recent eruption looks like it was maybe about 250 years ago. Previous to that one, it looks like there was a gap of almost, well, here's 500, probably about almost 700 years. Okay.